let's go to our next section, 5.7, inverse trigonometry function integration. In the book, theorem 5.17 is integral involve inverse. Alright, so let's look at the first one. I have an integral of du over square root of a square minus u square. A here is the number, a real number that bigger than 0, and u here can be variable or expression. It's gonna equal to r psi u over a plus c. Now let's look at my first example. I have an integral dx over square root of 1 minus 4x squared. It looks like we can apply the first definition of first part of the theorem here. So my a would be 1, my u, because we have u squared here, so my u will be 2x. If I square the u, I get 4x, so it's a squared minus u squared. And my du will be 2x dx. However, to get my du, I need 2 dx. So I'm missing the 2, so I multiply here by 2 and 1/2 outside. After that, I have my du, a square minus u square, which fit this formula. So the answer will be 1/2. 1/2 is come from this 1/2 here. Outside of my u, which is 2x, my a, which is 1. I didn't write down the 1 here because it's 1 divided by anything, it's just that, plus c. Alright, so that's the answer. Now let's look at my second formula here, an integral of du over a square plus u square equal 1 over a tangent of u over a plus c. It's similar to my second example here. My a, if I let my a be 2, then I have a square. If I let my u be x minus 3, then I have u square here. So I don't have to modify anything. It's fit the formula perfectly. So it's just 1/2 tangent of u, which is x minus 3 over a, which is 2 plus c. Look at the last formula. An integral of du over u square root u square minus a equal to 1 over a secant absolute value of u over a plus c. It's somewhat similar to this. It's not fit perfectly. We have to modify it a little bit. So let's look at inside. So my u square. So my u should be x squared because u square will be x to the 4th. Again, my a is the number. Since it's 4, then my a should be 2. Du should be 2x dx. So I need du. Du is 2x dx. I only have dx. So I'm going to multiply by 2x to get 2x dx. I multiply by 2x on the numerator. I multiply 2x on denominator because this is a fraction which is equal to 1. And then u. My u is x squared. My u is x squared. So I need x times x here is x squared. So I pull out the 1/2 here. I got my du here. And I got my u square and a square. It's perfect fit after I rearrange things a little bit. So the answer will be 1 over a, which is, oh, so I'm sorry, 1/2. This 1/2 is come from this 1/2. And then 1 over a secant absolute value of u, which is x squared, over 2 plus c. And then I multiply the 1/2 to 1/2, then I get 1/4, and everything else remain the same. Alright, let's look at more example. Hi everyone, let's finish our section. I have 2 more examples which require a little bit of technique. Let's look at this example. I have an integral from -2 to 2 dx over x squared plus 4x plus 13. It doesn't fit our formula anywhere. So I'm gonna make it fit by put in a form of perfect square. You're gonna have a square and u square somehow. So this part right here, I'm gonna make it perfect square by using complete square. If you don't remember how to do complete square, it's in intermediate algebra and pCal. So basically I divide 4 by 2, which is 2, then I squared, then it's guaranteed I'm gonna have perfect square. So basically I have x squared plus 4x and divide this by 2 and square it, then I have 4. Because I have 4 here, I need -4, so it doesn't change the value of the original one. So as you can see, this is a perfect square, which is x plus 2 quantity square. Now -4 and plus 14, also perfect square, which is 9. That make my a equal to 3, my u is x plus 2. So I can apply this formula here. So I just apply the formula and integral from -2 to 2. My du is just my dx and 1 over a. So 1 over a arc tangent of u over a, take an integral, lower limit is -2, upper limit is 2. Substitute it in, arc tangent of 0 is 0. So my answer is 1/3 arc tangent of 4 over 3. Now let's look at last example. This one I can apply the first method that I did, but I noticed that if I take derivative of x squared, I got 2x, and if I take derivative of 2x, I get 2. So I need to have 2 here. So what I did is I add 2 to make it the same value, then I have to subtract 7 because plus 2 and minus 7 is -5. Then I take it into 2 parts, the same denominator. The first part is 2x plus 2, which is derivative of 2x squared plus 2x plus 2. And I can apply this formula here. So from here, I apply this formula. So I have Ln, my u is x squared plus 2x plus 2. And then I just plus c, which is constant here. The second part is 7 over x squared plus 2 minus 2. I'm gonna force it to be in the form of a squared plus u squared again. So I take the 7 out, plus 2 here, I break it down to plus 1 and plus 1, which make this second term perfect square, which is x plus 1 quantity square. Of course, my 1 here is just 1 square. Then I can apply this formula here. So my a would be 1, my u would be x plus 1, and it's fit this formula. So the first part I'm done. I don't have to do anything. The second part is just -7 tangent of u, which is x plus 1, plus c. Now this 2c is just constant, different c, so I call it c2. Alright, we finished 5.7. Have a good day. Bye.